Thank you so much for listening to American Medicine Today. I am alongside Ethan Euchre.
It's always a pleasure to be here.
It is, but right now, with an average of 22 people dying each day while waiting for an organ transplant, the need for a solution is dire. And joining us right now is Dr. Jeff Ross, CEO of Miromatrix, a revolutionary company that is bioengineering transplantable organs. Thank you for being with us, Dr. Ross.
Well, thank you for having me.
Absolutely.
Now, Dr. Ross, this stuff is way over my head. I mean, luckily your website, Miromatrix, has videos to help simple-minded like myself understand this. But with all the heavy science here and limited time, can you talk about a little bit the core technology of Miromatrix and how it works? Something called perfusion decellularization and perfusion recellularization. It's really cool.
Right. Thanks. And it is a mouthful, as you noticed there.
Mm-hmm.
But really at the core of it, it's actually quite simple technology. And it's the notion of taking a pre-existing organ. So what we actually start with is a pig organ, whether that was a liver or a kidney, a lung. And we know today that we can't replace those organs into human organs because our body will reject it. So we use a process called, as you mentioned, perfusion decellularization, which essentially, simple terms, we just hook a tube up to the organ, we flow a mild detergent through it, which rapidly removes all the cellular material, leaving you with the decellularized organ. What I say it's analogous to, it's kind of like remodeling your house. So if you think of your house and your drywall or your sheetrock or the cells, we just go in and remove that. What that leaves you with is that perfect skeleton or structure of an organ, including the architecture. So all the plumbing's there, a kitchen's still a kitchen, a bathroom's still a bathroom. Same thing inside of our organ. That
was a great analogy because you're left with the foundation, or I'm guessing that's where the matrix part of Miromatrix came from. And it was really cool to watch the videos. I know Kimberly has seen it. When you see this super, red, coppery looking liver, and then after this process, it's completely like clear, whitish. And so now you're able to inject human cells into this pig organ?
Yeah, that's correct. So many people have kind of called it the ghost organ if you see it on the website, right? Because you took something that was pink, had all that blood and cells in there, you removed it all, and what you're left with is just that native scaffolding or matrix, and it's completely white. And it's really primed at that point to receive cells. So now we can take human cells and fuse those in to essentially reanimate the organ.
And there's no problem once you decellularize these organs. There's no problem once you add everything back in. They still function the same?
Right. Well, that's our hope. That's really what we're doing on the research is let's take something that nature already created and recreate that organ in a human form that now we could transplant into patients and not have that level of rejection that you would have had with a xenograft, and essentially be similar to transplantable organs that exist today. And we know how to immunosuppress and the regime and medical treatment to allow those implants to be functional.
And so the idea is, because there's such a shortage of organs, that if you can turn essentially a pig organ or some other mammal's organ into a human organ, have you done any
success?
Yeah, I mean, have you had any testing as far as whether it will be accepted into a human body, or are you still sort of in the trial stage?
So we've done some of the initial testing, and that is that notion of, I often say this to people, and they say, wow, this sounds really science fiction. And then they draw down and they're like, wow, this actually seems like it could work. But how do I know that once you remove the cells from that pig organ, that my body, humans aren't still going to reject that? So early on, we actually created medical devices. We sourced whole porcine livers. And the reason we're starting with pig organs is there's an endless supply due to our food chain. And many of these organs are just discarded or put into rendering. So there's an endless supply of available organs to be able to use our technology for. And early on, we actually took whole pig livers, used that process, decellularized them, removed all the cellular material, and we created medical devices. We created a product called Miromesh, which is a surgical mesh, and Miroderm, which is a wound care product. Got FDA clearance for those, and they've been implanted in thousands of patients with really good results and no rejection. So now, we're very confident from the safety standpoint that the matrix itself is not immunogenic because we have that human clinical data. So now we're able to take the human cells and add those on, and that's the phase that we're in right now, is putting human cells back on there and demonstrating that functionality.
And then it'll be utilized in human trials at that point?
That's right. So the next major step is to be able to demonstrate that this works in large animal studies and that they're functional. And then that will allow us to go forward with human clinical studies, demonstrate the safety and efficacy, and then eventually be able to create those for patients.
I know you said in the video that I watched on Miromatrix website that a lot of people, when they first hear about this, they see what you're doing, they say, well, this is years and decades potentially away from being applicable widespread. And you said not necessarily. So and I know that scientists never like to jump the gun in predicting things, but what is your time frame in your own mind?
We're making great progress. We just published a couple months ago in Nature Biomedical Engineering, where we actually could take that decellularized pig liver, we then recellularize it with human endothelial cells. Those are the cells that sit inside your vessels. And you've got to be able to reestablish that vascular supply, because if you can't perfuse blood back in and have blood come back out, you're never going to be able to create a functional organ. That was the first major barrier. We demonstrated that with human cells, we can recellularize that organ. We can get long-term perfusion inside of a large animal model. So that was the first barrier we're able to overcome. The next barrier is now put in the liver and kidney-specific cells and demonstrate that they have functionality. And we've demonstrated that on the bench and demonstrate that we have good functionality for there. And now we're in the middle of the studies of actually recellularizing the whole organ and placing that back into large animal models and looking at that functionality. So long-winded way of saying, if I look at the data today, it looks very promising. If we continue to progress on the rate that we're doing, we're targeting initial human clinical studies probably in the late 2022 time range. So we're not talking decades, right? We're talking
right around the corner.
Yes.
Yeah.
Right
in
around the corner.
A couple years, yes. Amazing sci-fi-esque technology that can potentially help thousands.
Well, just
millions
imagine all
even.
the thousands and millions,
Yes.
hundreds of thousands on these organ waiting lists. I had a friend who tragically passed away just a couple of years ago waiting for a liver. So it is very important.
It's another
science.
potential viable option.
And that's what really drives us at Miromatrix, and that's our mission, to eliminate the organ transplant waiting list. My grandma unfortunately died while on dialysis. I mean, the need is very, very great. And the other thing that drives us is once we're able to bioengineer organs, you don't have patients waiting around, waiting for that phone to ring. Hey, we have it. You got to report at this time. These procedures could be scheduled weeks in advance. Transplants could be occurring, for the patient and the transplant surgeon during the day when more resources are available. So we really see it impacting medicine, patient lives. I mean, it's just such a huge problem that we need to solve.
It most certainly sounds like it would be a very rewarding job for you. Dr. Jeff Ross, CEO of Miromatrix, a revolutionary company that's bioengineering transplantable organs. Thank you for sharing your time with us.
Thanks, Dr. Ross.
Thank you guys for having me.
Take care.
Have a great day.